Alright, the purpose of this video is to help you factor trinomials that look like this. And we're only going to do ones in this section where the thing in front of the x squared is a 1. So there'll be x squared plus something x plus something. So they'll always have that sort of form to them. Okay, again, just reiterating the fact that when we factor something, we're taking a polynomial, and in this case it's a trinomial where I have something squared plus or minus something x plus or minus a number, and we're trying to factor it or express it as the product of two factors. And again, this is the opposite to what we did in the last section. The last section we took this and we simplified it, or we multiplied it. Remember the x times the x, x times -5, etc. So that was simplifying or multiplying, and going back is factoring. Now simplifying is pretty straightforward. You've just got a step, right? X times both of these guys, 3 times both of these guys. But when you're factoring, it's not as simple a kind of thing because you have to come up with what those factors are. So, if we see anything that looks like this or like this, we can factor it, express it as the product of two, in this case, binomial factors. Binomial meaning they've got two things inside there. Okay, so why don't you take a look at these three examples and see if you can determine what kind of pattern is happening. I'm specifically wanting you to look at this number, and then these two numbers there. Do you see some kind of a pattern involved in that? And when I say pattern, I'm looking for maybe things that multiply or subtract or divide or add to get one thing and to get another thing. Okay, you seeing anything there? How about this one? I've got a 7 and a 12. And over here I have a 4 and a 3. Is the pattern you saw there current in this pattern as well? And if it is, test it on this one. Hopefully you're seeing some kind of a pattern. What's happening is that these two numbers here, they have to do two things. They have to multiply to get to this number, and they have to add to get to that number. So every time when you're factoring something like this, you can look for two numbers that multiply to 6 and add to 5. Two numbers that multiply to 12 and add to 7. Multiply to 15, add to 8. And that pattern is sort of what we look for all the time. And it turns out that you can tell one exactly, but often you're trying, especially when there's subtraction involved. Often you're trying one and you're multiplying it to check, or it'll take you maybe more than one shot to get it. I'm going to go through in this video just a series of a ton of different factoring and scenarios and see that that pattern exists all the time. So here's an example. I want to factor this polynomial. I want to get it so it looks like this. Okay, I know if it's x squared, the first two slots are x and an x. But now I got to figure out what those other numbers are. So what I'm looking for is I'm looking for things that multiply to 30 and add to a positive 13. So things that multiply to 30. 3 times 10, but that adds to 13. Oh, that's the one I want. Let's see another one. How about 6 times 5? But that adds to 11. How about 15 times 2? That adds to 17. So you can see that the one that's going to work is this top one right there. So what I do is I take this 3 and I put it in one of these slots. Notice it's a positive 3, so I would put plus 3 here. And this is a positive 10, so I'd put plus 10. If you want, it might be a good idea to check that. So x times x is x squared. X times 10 is a positive 10x. 3 times x is a positive 3x. And 3 times 10 is a positive 30. notice that for sure I get the first and last terms right. But then if I add these two, I also get the middle term right. Therefore, this here is my factorization. Let's try a couple more. And again, feel free to pause the video and then start up again once you get it. 30 and 11, I think we just did one of those. 6 times 5 is 30, and it adds to 11. Those are my numbers right off the bat. So I'll put a positive 6 there, positive 5. Let's look down below. Hey, same numbers. So 6 times 5 is 30. 6 plus 5 is 11. Oh, that's a negative 11. It has to match with sign. So, how about negative 6 times negative 5? That'll give me a positive 30. But when I add those together, it gives me a negative 11. So those are my ones that I'll want to use here. So I have a minus 6 and a minus 5. Again, I could multiply that out to check, and that's always a good idea to make sure, and typically this is the one you're trying to make sure that you get correct. Okay, we've seen a couple, and we've seen these examples here, and hopefully you notice that there's a pattern there. If this last number is positive, that each of these terms here have to be the same sign. And the sign that they are always whatever this sign is. So if the last term or the constant term is positive, these two have to be the same sign. And the sign that they're going to be is determined by whatever sign that is. So in this case, this is what I come up with. Here, last term's positive, therefore these have to have the same sign. And in this case, because this is minus, they're both minus. Now, when you're doing the actual question, a lot of that stuff just sort of works out, but that's not a bad thing to sort of keep in mind. You'll see that when this is negative, there's another pattern. So like for example here, this is positive and this one's negative, so that means both answers have to be negative. So it would be negative 15 times negative 1 or negative 5 times negative 3. Turns out that those two there add up to a negative 8, so it's got to be these two right there. So my factorization would be x take away 5, x take away 3. Again, try that one. Things that multiply to 20, but they're both negative. You could do the other way too. 20 times 1, negative 20 times negative 1, 6 times 5. Oh no, that's 30. Whoops. Not 6 times 5. 4 times 5. Oh, but that adds to 9. Oh, and I need negative 9. So it has to be negative 4 times negative 5. Those multiply to a positive 20, but they add to a negative 9. So this is the one that I want right there. So I've got t's this time, so it'll be a t minus 4 and a t minus 5. Again, notice the rule. Last sign is positive, and this one's negative, so they both have to be negative. Again, your factors sort of work that out for you. Let's try another one where this time the constant term, this one, is negative. So I'm looking for two numbers that multiply to negative 24. So they times to a negative 24, and they have to add to a positive 10. Okay, well, 6 times 4. So, but one of those have to be negative. So negative 6 times a positive 4. When you add those, down 6 gain 4, that'd be a minus 2. So it can't be that one. What else? 3 and 8. So negative 8 times positive 3. That gives me negative 24. But when I add, I get a negative 5, not a positive 10. That's not going to work. 12 times 2. One would have to be negative. So let's go 12 times negative 2. Add those together, I get a positive 10. Hey, that's what I have here. So those would be the numbers I want to use. So it'll be x plus 12, x minus 2. And again, not a bad idea to multiply those out and see if you come up with what you have there. Let's try this next one. Oh, there's something goofy here. Oh, it's not written in the right order. Let's write it in the right order. Y squared minus 4y minus 12. There we go. So I'm looking for two things that multiply to a negative 12, and they have to add to a negative 4. 6 and 2. So how about negative 6 times a positive 2? That multiplies to a negative 12, and it adds to a negative 4. And that's what I want, right there. Gee, I like it when I get them first time. So this would be y minus 6, y plus 2. Notice that if I write it like this, or if I write it like this, because of the commutative property under multiplication, it doesn't matter which order you write the factors in, they're both correct. Try some more. Maybe try these and then come back and see if you get them right. Again, wrong order, so it has to be a squared plus 10a minus 24. Didn't we do one just like this? 24 and have a difference of 10. Notice that it's a difference of 10 because it's you're multiplying to a negative 24. So over here, things have to add to a positive 10. It's going to be a difference because the two numbers have to be different signs. So again, I think the 12 and the negative 2, multiply those, you get that. Add those, you get that. Those are your numbers you want. So that can be, oh, it's up here. I can write it as plus 12 and minus 2. How about this bottom one? Wrong order. T squared minus 10t minus 24. Multiply to a negative 24, add to a negative 10. Hey, that's the same as the top one, but different signs this time. Before I wanted a positive 10, this time I need a negative 10. Maybe if I just switch those. So negative 12 and a positive 2. That multiplies to negative 24. It also adds to a negative 10. Those are my guys right there. So t minus 12, t plus 2 would be the factors of that polynomial. Okay, now how about what happens if you get a number where anything that multiplies to 7 times negative 1, either of those things don't add up to a positive 2. In this case here, at this point, we're stuck. We can't factor it into regular integral binomials where I'd have just a normal number there. We could still factor that, or if it was an equation, solve it, but we need a different tool in order to do it. For now, we don't worry about that one. Okay, just a couple last little things to look at when we're factoring trinomials like this. Sometimes you'll begin something like this where it looks different. Like here I have an x cubed. But if I notice that each one of these have an x, I could take out a greatest common factor of x. And then what that leaves me with is a trinomial just like the ones we were doing. Things that multiply to negative 12 and add to a positive 4. So 6 and 2, I think. So positive 6 times negative 2. Multiply those, gives me negative 12. Add those, gives me positive 4. Those are the ones I want. So this portion of the polynomial I can factor to x plus 6, x minus 2. And this x that was out front, I just leave it there. So this original polynomial is factored to this point here. The nice thing with factoring this, when we look at polynomials later, this tells me exactly how that polynomial will look like. It's going to look like this. It's going to go up like this, come down like that, and go like that. So once I've factored it, it tells me basically where things cross the x-axis when you're graphing it. And I guess you have to sort of know what the pattern of the thing looks like. But there's a point. I guess my point is that there's a point in factoring because it helps us graph things in the end. Okay, this other one, I can't factor anything out. There's no, oh, is there a common thing? A p. There is sort of a common p there, but there's not a common q. I don't know if this one's written out right. I think this is wrong here. I don't think that p is supposed to be there. I think it's supposed to look like this. At any rate, we've got p squared and q squared. If I can't factor something out, but it has sort of that general thing, like p squared, p, and a number. It's just that there's some q's messed in there. But maybe what would work is if I just forget about those q's for now, let's just work with the other things. Things that multiply to a negative 3 and add to a negative 1. That's the number up front here. So multiply to a negative 3. Negative 3 times positive 1, or 3 times a negative 1. Neither of those, though, are going to add to this one. Maybe I shouldn't have taken that p out. It looks, though, like I can't factor that with the normal trinomial, because there's nothing that multiplies to a negative 3 that also adds to a negative 1. So it doesn't look as though I can factor with that trinomial. So maybe it was, in this case, just pulling a p out. So a greatest common factor of p minus 3q squared, and that would be my factorization there. Okay, here's another type of thing, or I guess you can practice on here. This one's a little different, but it has a c to the 4th there, then a c squared, as opposed to a c squared plus c minus 56. But notice it has that same pattern. We can probably factor this just using a little bit of assumptions or guesses, but let's see if it works. Things that multiply to a negative 56 and they add to a positive 1. 8 and 7, so 8 times negative 7, those add to a positive 1 and they multiply to a negative 56. So I'm going to be putting a plus 8 there and a minus 7 there. Now in front, usually I would just put a c in this case, but because this is c to the 4th, maybe if I put a c squared there and a c squared there, maybe this will factor out properly. So I could multiply that, c squared times c squared, c to the 4th. This would be a minus 7c squared plus 8c squared. Notice when you add those, they're like terms. I'm getting a positive 1c squared. And then multiply 8 times negative 7 gives me negative 56. So that means this is correct, that factorization there. Here's another one. Common factor of 3 can come out. Oh, and an x. So I'll be left with x squared plus 20, no, not 24, 8x plus, I think that's 16. And the x goes out there. So I've got 3x. And now to factor this, things that multiply to 16 and add to 8. That's got to be 4 times 4. 4 plus 4 is 8. So this will be x plus 4 and another x plus 4. You could, if you wanted to, rewrite this as 3x times x plus 4 all squared. But both of those are correct. Okay. Another thing that you can do with polynomials like this to factor them, the problem with this one is I have this negative number out front. So how do you deal with that? Well, one way to deal with it is to factor just a negative number out. So I could factor out a negative 1 out of this. This will change its sign to a positive. This will change its sign to a negative. This will change its sign to a negative. So now I've got a polynomial, and this one looks just like the other ones. Things that multiply to a negative 18 and add to a negative 3. 6 and 3 has to be, so maybe negative 6 times positive 3. Those multiply to negative 18, and they also add to a negative 3. So those are my guys right there. So I'll leave the negative 1 out front, and inside here I'll have x take away 6 and x plus 3. Again, if you were to FOIL this out, you could FOIL that part out, should come up with this. Then when you multiply through by a negative 1, it should come up to what they had beginning. Here's another one, wrong order, right? So negative x squared plus 5x plus 14. I'm thinking 7 and 2 already here, but I have a negative out front. So I should factor out a negative 1. this will change from a negative x squared to a positive x squared. This changes to minus 5x. That changes to minus 14. Looking for two numbers that multiply to 14, or negative 14. Negative 7 times 2, 7 times a negative 2, that add to a negative 5. These ones add to a negative 5. These add to a positive 5. Has to be this one. So I leave my negative 1 out front, and x take away 7, x plus 2. There'd be my factorization of that one. Last thing to try in this section would be ones that involve fractions. Make it stop. Anyway, so factoring with fractions. Typically we give you nice ones with these, but if you have 1/9, the only way you can get 1/9 is going 1/3. I guess you could go 1/9 times 1, but you could go 1/9 or 1/3 times 1/3. That'll give you 1/9. And if you add those together, it does give you 2/3. So in this case here, I can factor it fairly easily. It'll be x plus 1/3 and x plus 1/3. And again, you could write them together if you wanted to. But that's how the fraction would be. Okay, that's a big section there. Lots to do. And lots to practice that. Getting in your head that you first take out a common factor, make sure your polynomial's in descending order, and then look for numbers that multiply to the last constant term and add to the middle x term. That's what you need to do with those. Practice a ton.